Hello, my name is RJ Podesky, and this project represents the work that Ernesto, Michelle, Dave, and I have done on visual analytics. So to give everyone some background research and provide you an idea of what we'll be chatting with you today is regarding primarily the use of visual analytics in the healthcare and network security spaces, primarily for improving patient healthcare and also for dealing with network security threats in the cyberspace areas. Organizations today are continually faced with an alarming amount of data coming into all of their systems from different areas. And these vary greatly in terms of their volume, in terms of quantity, their variety, both structured data that are represented in columns and rows in databases, and unstructured data from text documents, PDFs, videos, etc. In addition, the pace of this data continues to increase. The amount of data that an organization continues to gather increases at an alarming rate, but then also the amount of data that an organization can analyze is actually decreasing. This has certainly been a changing trend in business where the old paradigm might have been going with your gut or performing trial and error, as some authors have noted, but today most of our decisions in business have to be grounded in data and have to be backed up with the analysis that goes along with it. Visual analytics primarily deals with graphical representations, but goes well beyond the typical charts and graphs that we're used to seeing and working with. But it also brings in the predictive analytics component to be able to not just say, here's what has happened or what is happening, but also trying to do some forecasting of data, segmenting the data, and then also doing some correlation analysis as well in order to make predictions. Specifically, the two areas that we have looked at have been in healthcare to improve patient outcomes and in network security in the prevention of cybercrimes, as we see those breaches happen in the news almost daily. The whole idea, however, of graphical representations and visuals is not new. Back since the mid 1700s, a gentleman by the name of William Playfair is first credited with inventing the modern chart. And furthermore, another individual into the 20th century, Edward Tufte, is also he's a statistician and also an artist, and he's researched and authored multiple texts on not just visualizations in decision making, but also the beauty behind them and what stories they can tell us. As our brains are more wired for interpreting and making decisions with visuals and images than they are simply with seeing data in spreadsheet-like format. So the definition of visual analytics can be seen as the intersection between both information visualization, what we consider to be typical bar charts, scatter plots, line charts, etc., along with the idea of predictive analytics. Knowing that these can also be used to understand what could happen, not necessarily, as I mentioned earlier, what has already happened. Visual analytics can be seen used in several different areas, namely knowledge management, statistical analysis, the cognitive sciences, and also decision sciences. Wong and Thomas, in their work, noted that visual analytics is also the art of human intuition and the science of mathematical deduction to identify patterns for gaining knowledge. One of the things that is interesting is if we take a look at Google Trends and use the search term for visual analytics, we go back to when Google started tracking this for search trends, you can see that there was relative interest or half level of interest at the 50 mark back in 2004, and you can see that really starting to gain traction in 2012 probably when we start to see more information come out about big data and that growing in popularity, finding ways in order to make sense of that data. There are several products on the market that claim or have capabilities of doing some level of visual analytics. Tableau is certainly a popular product in the market that allows us to do more creative data visualizations that probably Edward Tufte would be more akin to, that go well beyond that simple bar chart, scatter plot, or line graph. Other capabilities built into visual analytics include the ability to do population density maps, and even include things such as simulations and or what-if analyses. This can be extremely helpful to actually see where population is moving over time. For instance, in that lower left-hand corner, maybe seeing population moving from the red area to the green area or back and forth, and creating animations to even seeing predictively where that may happen. Almost like we may see the future cast from a weather map like we see in the morning news. However, visual analytics isn't alone and being absolutely perfect. There are certainly issues that come along with visual analytics. Some of them are the size of the data set. Larger data sets, you may not have the hardware to be able to process that data set. You might have missing values. The data might not be consistent in the right format. There might be noise or significant number of outliers that skew your data set. User feedback in the application might not be appropriate, and there might be some other challenges within the visual analytics application that are difficult. But those that are successful in implementing visual analytics in their company not only have the technical skill set to be able to build these applications, but they also have the domain expertise. As some of you might be able to relate to, the data itself looks pretty innocuous unless you understand the domain and the context under which it's being viewed. And so the two contexts in which we specifically looked at were in healthcare and in network security. Specifically in healthcare, the use of visual analytics is being used to bring in data from multiple data sources to analyze, to be able to hopefully have better patient outcomes is the goal. In a recent poll suggested that 83% of executives expect to have successful IT implementations, in particularly on their resume. Authors have gone on to underline that spreadsheets and tables are often inadequate for clinical use. Visualizations make it easier for doctors and clinicians to be able to make decisions and avoid some common traps in data misinterpretation. And those misinterpretations lead to wrong diagnoses, missed warning signs for patients, and can be especially problematic in healthcare. Not only can visual analytics in healthcare improve patient care, but from an operational perspective, this can increase some efficiencies in hospitals and clinics. And it also, from a global perspective, when that data is anonymized, we can understand health trends geographically or within and among certain groups of patients with particular attributes, whether it be diet, exercise, gender, race, etc. One example of using visual analytics in healthcare, some hospitals, in particular one in Virginia, Augusta Health, they have used Tableau to overlay the hospital's floor plan, as you can see here by this graphic. And they've used it to be able to track infections and by patient room to understand where infections are coming from, and overlaying that information with their locations, test results, etc., so they can understand and pinpoint specific causes of infection and how that's being spread across a facility. This map in particular is an interesting corollary to the work that Dr. John Snow did in the 1883 cholera outbreak in London, where he went door to door to map the spread of the disease and ended up tracing its source to a water pump nearby. Originally, at the time, it was believed that cholera was spread by air only, and John Snow used it to be able to prove that it was spread by water through the pumps. And certainly London during that time in the 1880s was certainly lacking drainage and sewage and those types of modern amenities that we're used to today. Another use in the healthcare space is being used to extract useful information from existing literature and all the medical journals and research that's been done. Those three applications are Facet Atlas, DICON, and Solar Map. Facet Atlas provides the clinician a view of information from a variety of text-based sources to be able to do things like word frequency, stemming, building topics, and then map them accordingly and group those results based on the context of any given question that might be asked. So for example, a clinician could search for diseases grouped by symptoms or prognosis, and then they should be able to switch in real time and see the relationships between those results. Solar Map is a similar product or software that provides information about the relationships themselves and gives you some sort of timeline and grouping those topically as well. DICON, another application, looks at some of these concepts even further and allows professionals to manipulate the data by splitting, merging, regrouping, and filtering the results by similar patients in order to get a better picture of where those trends might be. So certainly areas in which healthcare can benefit from using visual analytics without pouring through mountains of data, where visualizations can certainly consolidate and make that easier for our brains to process once again. Another example of visual analytics being used is in the network security or cyberspace type of areas. Many of the applications that were used in the early days of networks were products like SolarWinds that provided us very convenient dashboard and monitoring tools, mostly letting us know what was going on at the time, or maybe particularly what has happened in the past. Those were very reactive tools, and they weren't able to necessarily tell us where a potential intruder might be coming from next, only where they might be attacking right now. Using visual analytics in this space has allowed companies to be able to recognize risks more ahead of the curve, be able to protect against future cyber threats or existing cyber threats, and it's been able to enable a key aspect of digital forensics nonetheless. One product here that is an incredibly creative way of representing network data is called InflowViz, and this graphic actually displays the communication flows between the source and destination hosts on a network. Another example here is called vAssist, and this is been deployed by the Department of Homeland Security and provides one view for in-depth analysis and another one as a dashboard view for some global activity. Author Wolf notes that visual analytics allows computer security professionals to rethink how to recognize risks and protect against cyber threats. In turn, this allows for more effective attack prevention and faster isolation and mitigation of attacks that do occur. Furthermore, with networks, actually one of the beginning stages of having to process mountains of data, as firewalls can bring together gigs of data in a matter of hours by logging destination and source activity. Tools such as these are incredibly important and even backed up by the Department of Homeland Security in identifying that being able to do automated analysis techniques and heavy interactive visualizations provides analysts, with better tools and a means to visually interact, explore, and analyze big, complex, and even sometimes conflicting data sources. These systems themselves, however, provide targets as well for attack, and so just as with other applications that exist, they also have to be secured, even though they become a very helpful tool in analyzing those data sets. In summary, network security tools provide automated analysis, again, techniques to be able to interact, explore, and analyze those data sets. And here's yet another tool where you can see network mapping and activity, again being able to show things like histograms and dashboards to be able to identify those particular incidents themselves. In summary, organizations continue to gather more data on a daily basis. And again, the ability for an organization to analyze more data as it's coming in at an increasing rate makes it difficult. And so visual analytics provides a succinct and elegant tool to be able to explore the data and help us make sense of it, not by using more primitive tools such as tables and graphs. Being able to also have predictive and prescriptive analytics insights allows us to even do this in real time. The whole idea, again, of data visualization is nothing new. Software companies are coming up with more creative methods to be able to visualize that data. Some of them are, as Tufte would say, works of art, but they also provide us with new insights and different ways to see our data. We've seen instances here today where, in healthcare, diagnostics is a matter of life and death, and being able to have the right tools in the hands of clinicians allows them to make better decisions for patient care, improve operations, and also do things such as reduce the spread of infection, and also go through numerous volumes of healthcare literature that one doctor would not be able to have the ability to do on his or her own, but be able to bring in all that information together to be able to provide better patient outcomes, diagnoses, and potential protocols for care. We've also seen network security grow in its importance, especially with cybersecurity being so important and attacks being so prevalent today. So there's so much data streaming, whether it comes from social media or even attacks from the web, primarily in Eastern Europe or Asia. We need to be able to recognize those potential risks, prevent attacks, and then collect the data for forensics so we can be better prepared in the future.